All right, so here is assignment 2.6. There's no lesson that went with this. This is just a review lesson, a study guide, a review lesson for the Unit 2. If you did have a Unit 2 exam, this would be one of the things you would do to help prepare to pass that exam. All right, so let's do and write. So assignment 2.6, you can put down your name and date and so on. I really think it is imperative that you do these questions first and then press play. This is not me teaching you now. You are practicing. I taught you this already. Can you do this first? So I'm going to write down the question and then I'm going to ask so nicely, please press pause and then answer it. I mean it. Press pause. Answer it. All right. So number one asks you to evaluate a limit. The limit is x is approaching 2 of f of x subtract 3. Now, when you have a continuous function, the limit and the function value are the same. So 5x subtract 3 is a line, it's continuous. So all you have to do is substitute in to find what the limit value is. It's only when we have discontinuities where evaluating a limit involves other techniques. So 10 take away 3 and the answer is 7. Number 2, write it down and answer it. Just copying my work is not going to help you be better. Press pause. Try. All right. Step 1 is to substitute in. If this is continuous at 3, you can plug in and get an answer. If it's not continuous, whole, asymptote, jump, then we might have to use other techniques. So substitute in 3 squared take away 9, 3 take away 3. You can see that this is indeterminate. Indeterminate, 0 over 0. We don't even write down 0 over 0, but understand that there's a hole, or could be a hole, in this function. So to find the limit, it is not continuous at 3. So the limit can still exist if something is not continuous there, because what is the y-coordinate it's approaching is what we're looking for. When it gets there and it's not, and there's no value, it's undefined, that's okay. A limit wants to know what is it as you're approaching it. Okay, so I'm going to see if I can factor. The numerator is the difference of squares. X plus 3, x subtract 3. The denominator, if I look now carefully, I can see that these, x subtract 3 and 3 subtract x, they divide out. But they're called opposite factors. And opposite factors means what you're left over with is negative 1. So now when you plug in 3 plus 3 is 6, but that negative 1 when you multiply means the y-coordinate is negative 6. And the limit exists. So at its very simplest, a limit question is a substitution question. It's when you cannot substitute in because there's a discontinuity that you have to use other techniques. What's the limit as t approaches negative 3? 3 plus t squared minus 9. So again, press pause, you first, then press play. Step 1 is substitute in negative 3. That's 0. Substitute in negative 3. That's also 0. This is indeterminate. So because it's indeterminate, I'm going to see if I can factor and still find the limit. So the numerator is fine. The denominator is going to be t plus 3 and t subtract 3. I want you to notice that 3 plus t and t plus 3, even though the order is different, they're exactly the same. They're not opposite factors. They're the same. You can add in any order. So they divide out and leave you with positive 1. Now when you substitute in negative 3, subtract 3, you get negative 6. So this whole number is negative 1 over 6. Number 4, write it down, answer it, then press play. The limit as x approaches negative 1, x plus 1, x squared plus 2x plus 1. Step number 1 is to substitute negative 1 in to find the limit. When I do that, I get 0 and I get 0. This is indeterminate. So I'm going to see if I can factor. Now, indeterminate means the limit exists or the limit might not exist. We don't know yet, but the limit could exist or may not exist. So don't assume because it's indeterminate that means the limit exists. Just assume there's another step to do. All right, the denominator. If I factor out the denominator, it's x plus 1 and x plus 1. I'm not going to write it as x plus 1 squared. So I'm just going to write it x plus 1, x plus 1. I want you to notice they divide out. But remember, 1 only takes out 1. One factor does not take out two factors that look the same. So just take out the 1. I'm left with positive 1 there. Now I'm going to do the same work. Now when I plug in negative 1, I get negative 1 plus 1. So now I have positive 1 over 0. Now I can clearly see what's happening. This limit does not exist. So again, I wanted to remind you, just because it's indeterminate doesn't mean the limit exists. It means there's another step to do. And we did that step. And you can keep doing that step of factoring or using the conjugate if it's indeterminate. As soon as this is not indeterminate. 1 over 0, that's undefined. 0 over 0 is indeterminate. So as soon as it's some number over 0, then I know the limit does not exist. That's mean girls. Full circle. Number 5. Press pause and write down the question and do your best. That's how you're going to learn. The limit as t approaches 2, and it's t squared subtract 4. It's t squared subtract 3t plus 2. Step 1, substitute 2 in, 0. Substitute 2 in here. That's also 0, so it's indeterminate. Does that mean the limit exists? Maybe, or not, but it does mean there's another step. So I'm going to write down the limit as t approaches 2, and I'm going to factor. So the numerator, t plus 2, t subtract 2. The denominator is going to be t, minus 2, and then t minus 1. So these simple factoring cannot take forever. So difference of squares, what two numbers multiply to 2 and add to negative 3? Both are negative. So t subtract 2, that leaves me with positive 1. They divide out. Now what happens when I plug in 2? So that gives me 4 over 1. I got that. So that exists, and that answer is 4. Number 6. This is a one-sided limit. The limit as x approaches 0 from the right. Now, for these, what I find easiest is to write this as one fraction. So I'm going to write down the limit as x approaches 0 from the right. If I wrote this as one fraction, think of it as a 1 down here, I'd multiply x cubed top and bottom. So x cubed times x is x to the 4th plus 1, and that's all over x cubed. So when I see it as one fraction, I can clearly see that at 0, there's a vertical asymptote. Nothing divides out. It stays there. It's non-removable. There is. What else do I notice? I notice that it's an odd asymptote. So to the right compared to the left. So because there's an asymptote, you could right away write down the answer is does not exist. Because in some mathematical circles, it makes sense to say that you can never approach infinity or negative infinity. But you could also write the answer this way. Does it approach infinity or negative infinity from the right? So to the right of 0, plug in 1 or 2 or 3 or 4. You need to understand that a vertical asymptote, it's either going to infinity or negative infinity. Those are the only choices at a vertical asymptote. So when I plug in a number bigger than 0, because the answer is positive, I know this is going to positive infinity. If I plugged in a number less than 0, like negative 1, the negative and the cube, that actually makes a negative answer, which makes the left side going to negative infinity. You could also see that an odd vertical asymptote means one side goes up and the other side goes down. Number 7. The limit as x approaches a half. This is a double-sided limit, or two-sided. 4x subtract 2, 2x subtract 1. When I substitute in 1/2, that's easy. Half of 4, that's 2. Take away 2, that's 0. Half of 2, again, That's 1 take away 1. This is indeterminate. So when you plug in a half, you get 0 over 0. So there's another step to do when you see indeterminate. And that next step is to factor. So in this case, I'm just going to factor out a common factor, which is 2. And that leaves me with 2x minus 1. So when I divide out, remember I'm left with 1 when you divide out. Now, there's no variables even. So the answer is exactly what you see. So when it's a constant and approaching it, the constant is the answer. So 2 divided by 1, there's no variable to plug in. The answer is just 2. Number 8. So again, be great if you could first try and then press play. In this limit question to evaluate, step 1 is to substitute in. It is indeterminate, which means there's another step to do. The next step to do is to see if I can factor. X to the 4th minus 1 is a difference of squares. So the square root of x to the 4th is x squared, and it'll be x squared plus 1, and then the other one will be x squared subtract 1. Next, I can continue to factor. Now, x squared plus 1 is prime, but x squared subtract 1 is a difference of squares where I can do it a second time. So a difference there would be the square root of x squared, the square root of 1, so that's x plus 1, and x subtract 1. Now it's completely factored. So x subtract 1 divides out. Remember, there's a 1 left over. When I plug in positive 1, I'm going to get the answer. Now, I know plugging in positive 1 is not going to give me a 0 in the denominator. So just let me take my time. 1 plus 1, 1 plus 1. That's 2 times 2. So the limit here is 1/4. Number 9. The limit as x approaches 1 of x squared subtract 2x plus 1 over x minus x plus 1. Step 1 is to substitute in. Step 1 is see if it's continuous at 1. So plug in 1, and the numerator gives you 0. Plug in 1 on the bottom, and it's 2. This is not indeterminate. 0 over 2. So the answer here is 0. 0 on top, good. 0 on the bottom, bad. However you want to remember it. So 0 divided by a number is great. That answer is 0. A number divided by 0 doesn't exist. Number 10. The limit as x approaches 1. And here again, a similar question. So in this example, when I plug in 1, I actually is indeterminate. Notice the difference in the denominator. So when I plug in 1, I do get 0 over 0. So that means there's another step to do. I'm going to factor the numerator. So what two numbers multiply to 1? That'd be 1 times 1. Both need to be negative for it to match, so we get negative 2x. Notice that 1 only takes out 1. So when they divide out, I'm left with a 1 in the denominator. Now plug in 1, and I get 0 divided by 1. And again, my answer here is 0. Notice, if you have a 0 in the numerator, that's okay. It's the 0 in the denominator that makes it undefined or does not exist. Number 11. The limit as x approaches 2. 3x plus 5. 5x take away 2. Step number 1 is to substitute in. Is it continuous at 2? So in the numerator, I get 11. The denominator, I get 10 take away 2. So the answer is 11 over 8. It is continuous. So since it's continuous, the value when you substitute in is what your limit's approaching. That's it. Number 12, the limit of as x approaches 2, and it's 1/2 take away 1 over x, and then x subtract 2. So when I look here, I plug in 2, and I get 1/2 take away 1/2. That's 0, and 2 take away 2 is 0. This is what? Indeterminate. What does that mean? I don't know yet. That's what it means. That means there's another step. So what's the step going to be here? There's nothing to factor. So the next step is going to be to write the numerator as one fraction and go from there. So if I write the numerator as one fraction, the first fraction needs an x, top and bottom. The second one needs a 2, top and bottom, so it can match. And then the common denominator would be 2 times x, right? 2x. The next step is to know when you divide, you multiply times the reciprocal. And the reciprocal of the denominator is 1 over x minus 2. So then you can clearly see the whole that divides out. Remember, you're left with 1's here. Now we can plug in 2. So 1 times 1, 2 times 2 times 1, and you can see it's approaching a quarter. Number 13. The limit as x approaches infinity. These are end behavior questions. So when I write down the limit as x approaches infinity of x squared subtract 9 and 2x squared plus 9, what I'm asking for is either the right end or the left end. So positive infinity means what's the right end behavior? And how do I understand the end behavior? Is power over power. So this is the same as, what's the answer when x approaches infinity of x squared over 2x squared? So the power term on top over the power term on the bottom. Notice the x squares divide out, and you're left with a constant. And every time you're left with a constant, that is your answer. So that means there's a horizontal asymptote at y equals a half. That means the right end is getting closer and closer to 1/2 as you plug in large numbers for x. 14. Again, end behavior question. So as x approaches infinity, that's right end, we have 2x minus 1 squared over x squared subtract 9. Do you recognize the power terms? So in the numerator, be careful. We have parentheses here. So that square belongs to the 2 and x. That means I have to write 4x squared and recognize that. The denominator is just x squared. That's the power term, the term with the biggest exponent. The x squares divide out, and you're just left with 4. Both the right and left end are going to 4. 15. Again, an end behavior question. Notice now negative infinity. So this now is the left end I'm looking at. So 3x squared minus 5 over x plus 1. Power over power. So the limit as x approaches negative infinity, the power term on top, the power term on the bottom. I want you to notice that the top is more powerful. That means the ends are going to infinity or negative infinity. So when I simplify it, it's just 3x. Now 3x is just a line. It's a positive slope line. So if I draw a positive slope line, the right end's going to infinity and the left end is going to negative infinity. And because they're approaching negative infinity or positive infinity, you can also write down that it does not exist. Number 16. The limit as x approaches infinity of 2x and then x subtract 3 squared. So identify the power terms. Know it's the right end. Sometimes both ends go to the same number, and sometimes they don't. So we need to recognize the power term. There's only one term on top, 2x. And the bottom, if I expand it, the most powerful term is x squared. Notice the bottom is more powerful. Whenever the bottom is more powerful, that means both ends are going to 0. Always. 17. Here is a one-sided question. So the limit as x approaches 2 from the left. And I'm going to factor this right away. That's x plus 2 and x minus 2, a difference of squares. What's happening at positive 2? Well, it's not removable, so there's an asymptote. Is this asymptote even or odd asymptote? So when you plug positive 2 into x subtract 2, that's where the asymptote is. So what's the exponent on there? For both of them, they're odd. What does that mean? One end goes up and the other end goes down. If I plug in a number bigger than 2, like positive 3, notice the answer is positive. That means the right end goes up. And because it's an odd asymptote, that means the left end goes down. So to the left of 2, it goes down. Or again, you can write down does not exist. 18. The limit as x approaches negative infinity, that's the left end of negative, and it's the square root of x squared over x. So recognize this. The power term on top is the square root of x squared, which is x. And we have an x, the only term in the denominator. Now, the thing we need to worry about is this minus sign. Now, when I take the square root of x squared, like solving a quadratic, the answer could be positive or negative. For the left end, it's going to be negative. But we still have a negative in front. So for the left, I write negative x. If it was the right end, it would be positive x. Plus, we have a minus sign already in front as is. Now, we simplify this. A negative times a negative is positive x divided by x. The left end is going to positive 1. And if it was asked for the other end, probably, does 19? No. If 19 asked for the other end, the right end, you'd say negative 1. So 19, the limit as x approaches 2, you know I love my step functions, x divided by 3 plus 5. So for this step, recognize when you plug in, if the answer is an integer, then there's a jump there and the limit doesn't exist. But when you plug 2 in here, 2/3 plus 5, what you're really looking at is this. That's not an integer. And what those bars, those double bars mean is, what's the greatest integer less than or equal to that? So that answer is 5. And that's what the limit is. If you plugged in 3 and that gave you an integer answer, there's a jump there and it would be does not exist. So again, plug in 2, I have my number, and you say to yourself, what's the greatest integer less than or equal to that? So the biggest integer that's less than 5 2/3, and the answer is 5. 20. Same question, but from the left. So the limit as x approaches 2 from the left. Now, because there's no jump there, because it's in the middle of the step, the answer is exactly the same. So that would have some power to it, having a minus or a plus sign, if there was a jump there. But there's no jump there at 2. You just plug in and get your answer. So the left and the right, if it was a plus sign, it would give you the same answer. All right, 21. The last of these type of limit questions. The limit as x approaches 3. Oh, here it is. And it's x divided by 3 plus 5. So what happens here is when you substitute 3 in, 3 divided by 3 is 1, and 1 plus 5 is 6. It is an integer. So whenever you have an integer answer, at every integer there's a jump. And if there's a jump in the graph, the limit does not exist. Right side does not agree with left side. All right, 22 to 30, we have to look off a graph. So we're going to look off the graph and then just put the answer down here without showing much work other than talking about it, so now that you understand how to interpret a graph. So I'll put the answers on the paper too, like you should when you take your picture of your work. But let's look at the graph here, and can we look off a graph to know what a limit is? So the limit as x approaches -1. So where's -1? There it is. So from the left and from the right, what y coordinate is it approaching? This here has no consequence. Look at the left and the right. What's the y coordinate? It's okay, there's a hole there. And the answer is +1. 23. This is not a limit question. This is what's the function value at -1. Now, when I go to -1, where is the y coordinate there? And the answer is 0. Now, this is a calculus definition of continuity. Is the function continuous at -1? If the limit and the function value have the same answer in calculus terms, that function is continuous. This function is not continuous. And we can see off the graph it's not continuous, that there's a hole there. All right, what's the value of f at 1? Not a limit question. So at 1, what's the value? And so you can see here the value is 0. 25. What's the limit as x approaches 1? So notice here at 1, from the right, it's approaching 3. From the left, it's approaching 0. They don't agree. There is no limit that exists because right side does not agree with left side. Again, not continuous. The limit and the function value need to be the same answer for it to be a continuous function. 26. What's the limit as x approaches negative 3? Find negative 3. From the left and from the right, they agree. The y-coordinate it's approaching is positive 1. 27. And notice that the function value and the limit equal the same answer, therefore it's continuous around negative 3, which it is. No jumps, no holes, no asymptotes. 27. What's the limit as x approaches 1 from the right? So from the right, the answer is 3. 28. End behavior. What's the right end behavior of this function? So where's the right end going closer and closer to? Notice that horizontal asymptote. So the right end is getting closer to 1, or it's approaching 1. 29, what's the left end behavior? No, 29, yeah, what's the left end behavior? So as x approaches negative infinity, it's asking for the left end. So what's the left end behavior here? So what is happening for the left end? Well, it's approaching what y-coordinate? And the answer is 0. And then the last of these kind of questions, number 30, looking off a graph. What's the limit as x approaches negative 2? So here we are at negative 2. The left goes to infinity. The right side goes to infinity. They're both approaching. So we could say the answer is positive infinity, or we could say it does not exist because it's not possible to approach infinity. Both are correct. All right, 31. Oh, it's still looking off the graph. In 31, could you list the removable discontinuities? Now this means the limit exists, but is not continuous. Here, the limit does not exist. That's how you know. So when I look at where the discontinuities are, for the x, the first discontinuity is at negative 2. Now, it doesn't, it's not included that the answer is positive infinity. So because one of the answers does not exist, that could be correct, that's what you go to for this one. And recognize that a vertical asymptote is not removable. So the first discontinuity is where x equals what number? Negative 2. Is it removable or non-removable? So at x equals negative 2, it is a non-removable discontinuity. And why is it non-removable? Because it's a vertical asymptote there. So vertical asymptotes have a non-removable discontinuity, and an answer there for the limit is does not exist. Where else is there a discontinuity? So keep going left to right. The next one is at negative 1. So at negative 1, there's a hole. Does the limit exist at that hole? Yes. So therefore, it's removable. Now, just because there's a hole doesn't mean the limit exists, but the limit can exist at a hole, but cannot exist at a vertical asymptote. So there's a hole and the limit exists, that's why it's removable. Where else is there one? There's one more, and it's right here when x equals positive 1. Notice there's a hole, but does the limit exist here? No, the right and the left, because there's a jump, the limit doesn't exist. And because the limit does not exist, how do we classify that discontinuity? That means there is a non-removable discontinuity. So in this case, we have a hole with a jump. That's why it doesn't exist. For the middle one here, the limit existed because the left and the right both agreed what it was approaching. Oh, 31 said list removable. Huh? I wasn't being a good reader. So 31, the only removable one was at x equals -1. And then 32, we'll call this 32 and this 32. Those are the two non-removable ones, at -2 and at +1, and we explained why that was the case. All right, 33. In 33, you're given a function. It's piecewise. So we have x plus 2. It's valid when x is less than or equal to 0, x squared plus 2. And that's valid between 0 and 2. And then just 2. So the answer is always 2 when x is bigger than or equal to 2. Okay. Now let's answer the questions. So the first one is, can you sketch that? So that's number 33. So let's do that. I know you can do it, and together we'll do it. So we'll for sure do it together. So when I sketch this, I first think of the domain restrictions and like where they break into pieces. So when I plug in 0, what's a point? So I plug in 0, 0 plus 2 is 2. So at 0, 2, we have a point because of the equals to part. Now what shape is this? Well, to the left of 0, it's a line. What's the slope of the line? +1. Now normally I would go up 1 and to the right 1 and draw it, but I don't want to draw it to the right. So if I draw this, I want to make sure that I'm drawing it to the left only, up to that point. So even though it looks a little confusing that the arrow is pointing down, think that this is actually a full line, but I'm only drawing it from -infinity to 0. So when x is less than or equal to 0, this is what the picture looks like. Now what happens between 0 and 2? So plug in 0 and I get the answer 2. So I don't need to put a hole over that, it's there. Plug in 2 and I get the answer 4 plus 2, which is 6. So 2 and 6. 1, 2, 3, 4, 5, 6, right here. Now, the only thing I need to be concerned about is what shape is this? So I could also plug in 1 to give me another point. So 1 is between 0 and 2. 1 gives me the answer 3. X squared plus 2 is a parabola. This is actually an HK form where the H is 0 and the K is 2, meaning that 0, 2 is the vertex. So it's just half the parabola going up here. Oops. And at 2, there's a hole. So at 2, 6, there's a hole. So I got carried away there. So there's a hole there, and it doesn't go beyond that hole. Next, the next part is 2. So at 2, the answer is 2. Remember, there's a hole here. And what does a picture look like? Well, when it's a constant, it's just a horizontal line at 2, and it goes forever to the right. So here's my picture of my graph. 33 is done. Now we're going to answer questions off that graph. 34 says, find the limit as x approaches 0 of g at x. So when I look at 0, does the left and right both agree what the y-coordinate is? The answer is yes. The answer is 2. For 35, what's the limit as x approaches 2 of that function? And here the answer is, it doesn't exist. The left says the answer is 6. The right says the answer is 2. That jump means the limit does not exist. 36. Still based on that graph. How about from the left? So the limit as x approaches 2. From the left, what's the answer? So off the graph from the left, the answer is 6. That's what the y-coordinate is that's approaching. How about the limit as x approaches 1 off this graph? So if I look at 1, I even solved for it. It's on my graph. It's continuous, so just plug in 1 into the middle piece, and we said that answer is 3. And because it's continuous around 3, you just plug in to get the answer. 38, still off that graph. 38 is asking for the end behavior, the limit as x approaches infinity. What's the right end? Where is it going? And you can see the right end is just staying at 2. So the right end behavior is 2. 39. What are the discontinuities? Well, for 39, there's only one discontinuity, and it's at x equals positive 2. It doesn't ask, but we're going to do it. Is it removable or non-removable? And the answer is it's non-removable. Why? Because the limit does not exist at 2. All right, last question for this video. Then part 1 will be done, and then I'll do another video for the second half of this assignment. So you're given a function. See, I hope I have enough room here. X plus 1, x squared plus ax plus b. And the top one goes from 1 to 3, and the second one goes from 1. It says x is less than or equal to 1, or x is greater than or equal to 3. So I kind of messed up writing it down. Can you find where it's continuous for values for a to b? So step number 1 is to plug 1 into the top. That gives me the answer 2. Plug 1 into the bottom, and they have to give you the same answer for it to be continuous. So if I plug 1 into the bottom, I get 1 squared, that's 1. A times 1 is A, and then B. Now, I'm just going to clean this up quick. I'm going to subtract 1, so 2 take away 1 is 1, and I have this left. Now I'm going to do the same work for 3. So I'm going to plug 3 into the top. 4 is my answer. I'm going to plug 3 in for x in the bottom. That gives me 9 plus 3a plus b. They have to give you the same answer for it to be continuous. So I'm going to subtract 9. In fact, I'm going to do that right here. So subtract 9. So 4 take away 9 is negative 5. And I have 3a plus b. And this is what I'm solving. So I have a simple little system. To solve this, to eliminate the b, I'm going to subtract. So 1 subtract negative 5 is 6. 1 subtract 3 is negative 2a. And then the b's, they eliminate. Divide, and you get the answer negative 3 for a. And once you know the answer for a, you can then plug in to find the answer for b. So I can do some mental math here. Plug negative 3 in for a. Add 3 to the other side, and you can see that a is equal to negative 3, and b is equal to 4. So those values would make it continuous. All right, Mr. G Math, over and out. I'm proud of you that you're doing your work. This is an important assignment, reviewing all the stuff that we've done the first couple units. All right, until next time.